So I'm Jasper from ETH, part of the SRI lab, and I created a work on contamination detection in large language models. Now, normally contamination is defined as a non-empty overlap between the training and the test set, but this actually doesn't work for large language models, and the reason why is very simple. Large language models are trained on very large training data sets, so it's actually just very likely that you train some benchmark samples in there, either rephrased, translated, a bit of them, whatever. And it's also been shown that actually methods that work based on this definition of contamination, membership inference attacks, don't work whatsoever. So what we do instead is performance-based data contamination, where we say a model is contaminated with a benchmark if it actually has non-generalizing performance on that benchmark. So the performance that you measure on that benchmark does not generalize to rephrased sample or synthetic samples from a similar distribution. And the way we do that is by constructing a reference benchmark that is in some ways similar to our original benchmark, and then compare the performance of the reference benchmark and the original benchmark. And if these two are significantly different, we can conclude that there is contamination. Now, the way we construct this reference benchmark is either by rephrasing our samples in the benchmark, or by asking GPT-4 to come up with some new samples from the same distribution. Now, unfortunately, GPT-4 is not perfect, so there is going to be some distributional difference between the two benchmarks, and the way we correct for this is by evaluating lots of different models on both the reference benchmark and the original benchmark, and then fitting what we call a hardness correction function, which basically maps the reference performance to the performance on the actual benchmark. And then, based on that, we can compute the difference between these two and get actually an estimate of contamination. And in our experiments, we show that it actually works quite well. We outperform all our baseline by like 70%, even for the ones that are realistic. And you can also see that our estimated performance difference is around equal to the actual performance difference when we contaminate or don't contaminate. Then we do this large-scale contamination analysis of over 50 models, and we find that top models on the OpenLLM leaderboards are very contaminated, but also, for example, that the Yeet 34 billion model is contaminated on several benchmarks, including the HelloSwag benchmark. Thanks.